All right, so we're going to look at these here. So starting in chapter 6, not chapter 6, chapter 5. Chapter 6 will be next. So first thing we're looking at is 6. I keep saying 6. Chapter 5 is going to be systems of equations. So we're going to look at different ways to do this: graphing, substitution, and elimination. Now the first thing we're going to look at is this one here. Determine if the ordered pair is a solution to the system. Now, for it to be a solution to the system, it has to work for both equations. So if we look at part A, here, 1/2 comma -5, we can plug it into the first equation. So we can say 6 times 1/2 plus -5 is equal to -2. And we want to see if this is a true statement. Now we can say 6 times 1/2 is 3 minus 5 equals -2. Bless you. -2 is indeed equal to -2. So that works. But we have to plug it into the other equation as well. So 4 times 1/2 minus 3 times -5 is equal to 17. Now on this one here, I mean, either one, we could plug this entire side into the calculator and let it do it for us. If we do it by hand, 4 times 1/2 is 2. -3 times -5 is plus 15. Equals 17. 17 is indeed equal to 17. So, yes, 1/2 comma -5 is a solution to this system. Any questions on this so far? Now part B, so we're going to try it again with 0, 2. So for the first one, we can say 6 times 0 plus -2 is equal to -2. 6 times 0 is 0. -2 is equal to -2. It works. And just because it works for one doesn't mean it will work for both. In the closet? Yes. So the light's straight ahead, and then halfway down on your left. It should be on the floor. It should be in a big box on your left. So. Now for the second one here, if we check this, well, 4 times 0 is 0. -3 times -2 is 6. 6 is not equal to 17, so no, it's not a solution. It works for one of the equations, but it doesn't work for the other, so no, it has to work for both. Now, if you're checking points, because there are some of these on the homework, and you plug it into the first equation and it doesn't work, it gives you a false solution or a false statement, you don't even have to check the other. Because if it doesn't work for one, it doesn't matter if it works for the other. It has to work for both. So once it doesn't work for one, it's no, we move on. Does that make sense? Solutions to systems of linear equations in two variables. So we can have one unique solution, no solution, or infinitely many. If a system of linear equations represents intersection lines, then it has exactly one solution. If we have two lines and they cross at a single point, we have one unique solution. No solution. If a system of linear equations represents parallel lines, then the lines do not intersect, and the system has no solution. In such case, we say that the system is inconsistent. Inconsistent. There is no solution. It is inconsistent. And if a system of linear equations represents the same line, then all points on the common line satisfy each equation. Therefore, the system has infinitely many solutions. In such case, we say the equations are dependent on each other. Now, there's different ways we can do it. So we can first look at substitution. When we solve an equation by the substitution method, we isolate a variable. And the main reason I would use the substitution method is if we have a variable by itself, there's not a number in front of it. We'll look at some later where even though it's squared, it still works out just fine. But here, since we already have y by itself, we're going to isolate that variable first. We're going to get it by itself. So the first thing we can do is subtract 4x from both sides, telling us that y is equal to 5 minus 4x. Now what we're going to do is substitute 5 minus 4x into y in the other equation, which will tell us that we have 5x plus 4 times 5 minus 4x is equal to 2. At this point here, we're going to solve for the value of x and go from there. So we can distribute the 4. 4 times 5 is 20. 4 times negative 4x is negative 16x is equal to 2. At this point, we can combine like terms, telling us negative 21x plus 20 is equal to 2. We can subtract 20 from both sides, telling us that negative 21x is equal to negative 18. Last but not least, we can divide both sides by negative 21, telling us x is equal to 6/7. Any questions on this so far? Now what we do next is we plug it back in to find the value of y. So we'll say y is equal to 5 minus 4 times 6/7. And we could plug this all into a calculator. And we get our answer. So it tells us the solution is 6/7 comma 11/7. It came out to be a little weird, but that's it. Any questions on this here? So They call it the addition method. We could call it elimination, either way. And with the addition method or elimination, we want both of the equations in standard form. Now for us, the negative 3x plus 7y equals 1 is already there. Our other equation, we need to rewrite it. So what we're going to do is subtract 4y from both sides, telling us that we have 5x minus 4y is equal to 6. Now, for us to be able to eliminate something, we need one of the variables to match. We need to pick one of the two variables to eliminate first. So we're either going to eliminate x first or y first. And it doesn't matter which. Here we can eliminate x. And to eliminate x, we need the numbers in front of x to be the same. Now, I'm not too focused on the sign. If one of them's positive, one of them's negative, both positive, both negative, it doesn't make too big of a difference there. But to get them to be the same, we're going to need to multiply this entire equation by 3. And we're going to need to multiply the other equation by 5. Because we multiply this one here by 3 on both sides. 3 times 5x is 15x. 3 times negative 4y is negative 12y. And 6 times 3 is 18. Here, when we distribute the 5 times negative 3x is negative 15x. 5 times 7y is plus 35y. And 5 times 1 is 5. Over here. So we could do negative 3, and that's fine. Because I can multiply it through by negative 3, and I'll write that out. Because if we did negative 3, because we can say negative 15 plus in here. And if we do this, because when we put it underneath it, here, I can just rewrite it. Use circle. So negative 15x. Okay, let me write. Apparently not. How much use should that? Negative 15x plus 12y is equal to negative 18. We can do that. See if they'll let me do it this time. But when we use our next step, we would add. So, yeah, so we can use the negative 3, and we would add at this point. Now, negative 15x plus 35y equals 5. If we just use 3, the signs are opposite, yes? But this time, instead of adding, we would, or sorry, here I have it backwards. If the signs are the same, we subtract. If the signs are opposite, we add. So that's why sign doesn't make a whole big difference, because I try to get the numbers to be the same, put them over the top of each other, and go from there. So if the signs of what we want to cancel are the same, we're going to subtract. Because negative 15 minus negative 15, well, the negative would make a plus, and that would indeed give us 0. The next one, 35 minus 12, is going to be 23y is equal to, well, negative and negative makes a plus. 5 plus 18 is 23. If we do the same thing over here, negative 15 plus 15, these will cancel still. 35 plus negative 12 is 23y. And 5 plus 18 is 23. So we end up getting to the same place. And sometimes I find it easier to just get the number to be the same and not focus so much on the sign. And then we can finish this out by Dividing both sides by 23, telling us y is 1. So we have our first solution. Now we need to find the second solution. And it doesn't matter which equation we pick. We could pick one of these two here, or I could pick one of the two I found here. I just have to pick one. I'm just going to pick the top one here, 5x equals 4y plus 6. 5x equals 4 times y plus 6. Well, 4 times 1 is 4. A little more room. 4 plus 6 is 10. Divide both sides by 5, telling us x is 2. So our solution is 2, 1. Questions on any of this here? Not too bad so far. And I mean, for this one here, we could have done it either way. And almost, we could have done it by substitution. Just divide this first equation, everything by 5. We have x already by itself. We can plug it in and go. So sometimes, depending on the setup, it's easier to solve it one way over another. Questions on any of this here? Now, if we look at this next one, solve this system, there's two ways we can go about it. We could solve it by substitution or elimination. The reason I say substitution is because if we look at this first equation, the y is already by itself. We don't have a number in front of it. So using substitution would actually be quite easy. Because what I could do is take it, minus 2x from both sides, telling me y is equal to 4 minus 2x. We could have just as easily got the x's to be the same or the y's to be the same and gone from there. Now at this point, we can take this here and plug it in for y, which will tell us that we have 6x plus 3 times 4 minus 2x is equal to 6. Here we can distribute the 3, telling us 6x plus 4 times 3 is 12. 3 times negative 2x is negative 6x is equal to 6. Well, 6x minus 6x is 0, yes? So it's telling us that 12 is equal to 6. Is this a true statement? No. Now, if we're solving by substitution or elimination, either one, and all the variables simplify out, they all cancel out, and what's left is a false statement, this is our no solution. Now, if what's left is a true statement, 0 equals 0 or 6 is equal to 6, then it's infinitely many. And if we go back, since this is a no solution for this one here, we would also consider it inconsistent. So it'd be no solution and inconsistent. You too. Because I think the only thing that's really new is inconsistent and dependent. Are really the only two things we're adding. So this here is no solution and inconsistent. And they will ask for that on the homework, inconsistent, dependent. Yeah.
Probably.
Yeah. Yeah, next time that happens where assignment pops up we haven't covered, just let me know. I'll
I didn't know since I wasn't here that day before, so I didn't know if you're like.
just go ahead and do it. Yep. Any questions on this so far? Now let's look at this one here. This one here, I would definitely do this one by substitution because one of the equations has a variable already by itself, yes? So we can go on and just plug it in. We can say 8x minus 4 times, or plug this in for y, 2x minus 1 is equal to 4. We can distribute the negative 4. Negative 4 times 2x is negative 8x. Negative 4 times negative 1 is plus 4. Well, 8 minus 8 is 0, telling us 4 is equal to 4. Is this a true statement? Yes. So that's telling us that it's infinitely many solutions, and we can say it is dependent. Infinitely many solutions, and it is dependent. And if we wanted to, I don't think it'll ask this, but if we wanted to, we could find solutions that work. So I could say x is equal to 2 and plug it in. 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. So the 0.23 is technically a solution. And it would work for both, because if I plug 2, 3 into the other one, 8 times 2 minus 4 times 3. 8 times 2 is 16. 4 times 3 is 12. We can pick any number we want, and it would give us a solution. Questions on any of this here? Yeah. I'm going to go back and make sure in a second, but I want to skip to number 9. Yes. Okay. A lawn service company has fixed monthly costs of $500 and variable costs, labor, gasoline, and depreciation of $40 per lawn. If the service charges $60 per lawn, write the cost function C of X for the company. So costs. So, well, $40 per lawn, $500 a month. So we can say what? 40x plus 500. And that's it. Revenue. Well, they charge $60 per lawn, so 60x. And C. Determine the number of lawns that must be serviced in a month for the company to break even. So if we're talking about break even, we're trying to see when these two equations will be the same, when they're going to be equal. Now there's two ways we can go about it. The first, we just set the two equations equal to each other. And solve for x. So we can subtract 40 from both sides, telling us 20x is equal to 500. Then we can divide both sides by 20, telling us x is, well, we're going to 25. So we got to mow 25 lawns to break even. In other ways, we can grab the graphing calculator. Say one of the equations is 60x, the other is 40x plus 500. Graph. Well, we can't see both lines, but if we go second trace intersection, first line, second line, yes. Yeah, it was too big of a change or too big outside the window for it to try to find it. But if we keep going down the table, and at 25, they are the same. So at 25 lawns, they've made $1,500, but they've also spent $1,500. But that's it with that there. And there are several in the homework where you set the equations up and then solve where they're equal or solve for a given amount. Yeah. Because that's an expensive service fee. Any questions on any of this here? We'll look at number 8, and then that'll be it. Up and down the river. A riverboat traveling upstream against the current on the Mississippi takes 3 hours to travel 24 miles. The return trip downstream with the current only takes 2 hours. Find the speed of the boat in still water and the speed of the current. Current, speed, rate times time is equal to distance. So a boat traveling upstream against the current takes, so upstream against the current takes 3 hours to travel 24 miles. Travel downstream takes 2 hours to travel same distance. Now they didn't tell us the speed, and they didn't tell us current. Now we could leave it as S and C, we can call it X and Y. It really doesn't make a big difference. Because if we're going upstream, we're going against the current. And if we're going downstream, we're going with the current. So our equation here, rate times time equals distance. So 3 times our x minus y should equal 24. Downstream, again, rate times time equals distance. Now the nice thing is with both of these equations, they are both equal to 24. So what that means for us is that we can set them equal to well, yeah, I take that back. Because setting them equal to each other would be very helpful if we had one variable. Here we have 2. So the first thing we'll actually need to do is multiply these out. So 3x minus 3y is equal to 24. Here we have 2x plus 2y is equal to 24. Now we can do this by elimination or substitution. I would do it by elimination. Now, we need to eliminate one of the two variables. Do we want to eliminate x or y first? Y'all can pick. Let's just do x. So to get these equal to each other, well, for the top equation, I need to multiply everything by 2. The bottom equation, we need to multiply everything by 3. If we multiply the entire top equation by 2, we get 6x minus 6y is equal to 48. Yes, almost. You know, well, it's not 48. I was about to say 48, but it's not 48. Because 3 times 4 is 2. 3 to the 1, 6, 72. There we go. So the last number is not ends up being the same. However, the x's are, and it does feel like, because my first instinct was that everything's going to cancel out. But since x's are the same, we subtract. 6x minus 6x is 0. Negative 6y minus 6y is negative 12 is equal to. Here we can subtract 48 from 72, which gives us 24. Exactly, divide both sides by negative 12, telling us y is indeed 2. So the current is 2. 2 miles an hour. Now we need to pick one of the two equations to use to solve from here. Really doesn't matter which one we pick. So I can pick the bottom one, 2x plus 2 times y. 2 times 2 is equal to 24. 2 times 2 is 4. Minus 4 from both sides, telling us 2x is equal to 20, or that x is equal to 10. Questions on any of this here? We good with this here, for the most part? But that's it for this here.